Hi everyone. In this video, we are going to understand how unsigned in integers works in MATLAB using different bit widths like 8, 16, and 32 bits. These programs demonstrate basic arithmetic operations such as subtraction, multiplication, and division, along with important concepts like underflow, overflow, and memory usage. By selecting different bit widths, we can clearly see how data size affects the result accuracy and memory consumption. These examples are very useful for understanding computer organization, em- uh, em- embedded systems, and the digital concepts. So we are heading to the first code. This code explains the uh, add of two unsigned integers using a user selected bit width. It takes two integer inputs and the required bit width from the user. Based on the selected bit width, the values are converted into unit 8, unit 16, and unit 32 data types and then added. The program checks for overflow by comparing the actual sum with the maximum value supported by the data type. For example, 252 for 8 bit and 2 power 32 minus 1 for 32 bit. It also calculates the memory usage using the WHOS command and displays how many bytes are used. This code clearly shows how increasing bit width reduces overflow by increases memory usage. Uh, and the explanation of second code is this program performs the subtraction of two integers using either 8 or 16 bit arithmetic. The first number is treated as the minus and the second as the subtractant. After converting the values into unit 8 and unit 16, subtraction is performed. Since unsigned numbers cannot store negative values, the program checks for underflow by verifying whether the first value is smaller than the second. If underflow occurs, a warning message is displayed. The program also calculates and prints the memory usage of the variable, helping us understand how many memory unsigned data types consumes. And the third code explains the multiplication of two unsigned integers using 8-bit or 16-bit arithmetic. The user selects the bit width and the numbers are converted accordingly using unit 8 or unit 16. After multiplication, the program checks for overflow by comparing the actual product with the maximum value supported by the selected bit width. If the result exceeds this limit, an overflow message is displayed. This code demonstrates how many multiplications can easily cause overflow in smaller data widths. The fourth code explains that a simplified version of subtraction. If subtracts two unsigned integers using 8 or 16 bit, after converting the inputs into the selected unsigned data type, subtraction is performed. The program checks whether the first number is smaller than the second to detect underflow. If underflow occurs, a message is displayed. This code focuses only on arithmetic behavior and underflow without including memory analysis. And the last code explains the division of integers using 8 or 16-bit. It checks whether the divisor is 0. If the divisor is 0, the program stops and displays an message to avoid runtime errors. If the divisor is valid, the values are converted into unit 8 or unit 16 and division is performed safely. This program demonstrates the handling of errors in arithmetic operations, which is very important in real-time systems. So these are the codes that uh, y- these are the codes that we used here. So thank you for watching my video.